Yes, so I'm with the embedded industry since inception in 1985, 1990s. So I have a big story to tell about it. I have the same challenge as everybody else. I have to compress it into 15 minutes. So probably I try to exceed the speaking speed of Pedro, you just heard before. I need this thing. Okay, so what I'm going to do is I'm going to explain you a little about what are we doing. We are a typically maker of embedded products. So basically the embedded market is split in two. Tier ones make their own products, or they buy off-the-shelf products from us or from our competitors. Then the characteristics of embedded computing. There are a lot of rules in the game for this. It's not all about battery life, I'm sorry to say that. Then how do we do software right now, and what is going to be our biggest challenge, and it's obviously it's CRA. I'm really going to rush through the slides. The embedded market is all about standards. Why? Because basically we're a lot of small companies operating in that space. Most of these companies are 300, 400, 500 million companies, and for bigger companies to adapt this kind of technology, you cannot have these kind of companies as a supply line risk. If somebody goes bankrupt, you cannot get products anymore. So the whole ecosystem is based on second sourcing. It also drives down the cost. It's the continuity. You can upgrade systems and whatever. But one of the most important things is supply line security. That's why bigger tier ones adopted this kind of technology. It's off the shelf. Edling has been instrumental in defining of this specification, and Intel, because Intel basically built this market from 1990, the embedded market, also have been instrumental in this one. A typical example of a product that is standardized, heavily standardized, it means there's hardly anything that we can differentiate on the hardware level. This is a computer module, it's focused on ODM designs. That means full proprietary things. It's speeding up the design because it includes a CPU, memory, and all the high-speed devices, and these things go into medical or whatever. So all these things look different. Why do I show this? First of all, our business model is not just purely the hardware, the functionality. It's the quality, it's the service that we provide with this product. The more services we provide, the less likely that companies will go with us instead of our competitors. It also means that one product like this probably specs into 20 or 30 different accounts. Every account is specific, different vertical, different operating systems. So most of these products, we have to support something like 10 operating systems. And that's probably a very, very big overhead. What are the players? Intel, of course, is big in this market. AMD, of course, it's actually 6, but they're still struggling to get into some of these verticals because they lack the domain knowledge. NXP is big. It's not targeting the Intel space, but it's a kind of sub-atom level. And it's not really that they deliver very high-end ARM designs, but their core knowledge of domain knowledge, of course, is industry, and that's where they're very, very good in. And then we have MediaTek and Qualcomm. So where did we enter? Qualcomm already said it correctly. They enter from the mobile space where there's a lot of investment in things like AI and everything else. So we see the newer applications probably will go to them. And they do attack the Intel space because it's i3, i5 performance we're talking about. Where is Edling? So the head office is in Taiwan, of course. A lot of Taiwanese companies operate in this space, and a lot of German companies operate in this space. We have production facilities, because production is very important for us, quality is very important, and we have a lot of R&D centers that is to support customers to get to the market. Because what I say, a lot of our business is basically ODM, and we use these off-the-shelf products to speed up time to market and raise the quality and drive down pricing. So what do we make? Very simple. Just do a Google search on a board level. We make a lot of boards, really a lot, too many actually. And we also make a lot of systems, way too many. So this is a very, very fragmented market, speccing into multi verticals. Who are our customers? These are real customers, so you know what we're dealing with. ABB Robotics, the big welding robots for automotive, That's where our products go into, real-time stuff. Anritsu, Keysight, these are the scope manufacturers. Our products are in these things. Ultrasound, Samsung, Siemens, and whatever, you will find it. So you see, this is all really tier one stuff, and the second source model is really important to them. So what is the size of the embedded computing market? What I said, actually you have to divide it in two. Well, it doesn't look so beautiful. In two, a lot of ceiling goes directly to the tier ones who still do their own design, but 50% of the market is actually occupied by companies like Advantech, Control, and AdLink. The market is at the moment something like 40 billion, and it's supposed to grow to 50 billion in 2013. AdLink is doing $350 million in that market. So besides the form factors, what are the key differentiators? Because you can buy mini ITX ports just around the corner, but it's a little bit a different offer. We have to support customers with very long product life, because some of these guys, they produce their equipment for 15 years. They're certified, they cannot change anything. That means we have to have very strict life cycle management. We're not allowed to change anything on these boards over their lifetime, or we have to do it in a very organized fashion that people can test it or whatever. High MTBF, because 24/7 operation of these things, and there are a lot of rugged variants. I think 50% of our product goes into those kind of market, minus 40, 85. Then, and that is really the key differentiator, our business model is low volume, high mix. And that's very different. What I said, if these chips go directly to a tier one, that's very high volume. We do the low volume, high mix. And that means we have a lot of overhead on the software side, because what I just said, doing whatever, 10, 20 different products with the same products and supporting that. So, is that a burden to us? No, absolutely not. Because basically we don't have to support anything. We're doing the hardware. We have a beautiful AMI UEFI BIOS. It's very high abstraction, and everything just runs on top. The only thing that we have to get involved in is Yocto, where we do BSPs, and then VxWorks and QNX. But all the other stuff is none of our problems. If our BIOS are solid, everything will work. So it's pretty easy. And this is really the business model that functions in the embedded market right now, and this is how we are structured. How is that with ARM right now? Really, it's true right now. This is typically the IMX 6th generation. We just take a U-boot, a binary, we take the kernel that we have at hand, and we put it on a Debian root file system, and then the customer goes with it, makes his application, flashes it in the product, and never looks back. So for 10 years or 15 years, they don't change anything. Because remember, our market says we don't want to change things because products are certified, you don't want to retest and have several so many different versions. So this is really a very good, very nice business model. Are we alone? No. Everybody's doing it like this. So, I mean, all the things that we hear, all the, software ideas and everything it is, in the real world, it's not really like this. What I said, it's just, we're just doing blobs at the moment. So this cannot go on, of course, because we're going to run into this one, CRA. The good news is that it has been extended to 2027. So a lot of companies only going to go bankrupt at that time, not now. So because really, it's a really very big shift. It's something that is not coming out of the industry. It's coming from legislation, and it's going to have very deep effect in the industry. So what will it change for us? We have to implement mandatory root of trust. We can do that, believe me. We're doing gaming where we already implement this kind of things, and medical devices also sometimes have this. But it's a big overhead. Secure key exchange, we have to set it up. It's going to cost us money. And then the biggest one is continuous security maintenance over a product's lifetime, OTA service, and the biggest headache actually is verification if all the operating systems still work. That's really the verification part is very bad. You should understand, we are purely hardware companies. We don't do continuous integration. We don't do good in those kind of things, and that's things like this are crying out for those kind of abilities. So where should we go? Because we cannot do OTA. We have to go back to where x86 is with ARM. And that means SystemReady is kind of a key value in this market if we can get this abstraction of us and them back into the ARM market. Now, with the SystemReady device tree, we are kind of getting there. I'm not so sure everything will work out of the box on top of that. First of all, we still have to verify these kind of things. Yocto is a different story. Yocto doesn't have OTA service, so that's a whole other problem. Of course, we can go to ACPI. We already did that. We have an Ampere ARM system, this 128 core. It comes from the, cloud infrastructure market, where we did that. But it's a lot of work to create a BIOS like that for a product like that. But it really works. Even Windows, I can just download a UUDP, I flash it on this thing, it works. So the abstraction is there, but the overhead is quite enormous. So I think everybody knows this. Device tree, ACPI, the amount of work is just massive. Then we have a lot of projects when we have the standard product where we do this, invest this money, then we still have to do the modification on the separate projects. So that device tree is also the best way forward. And then next to that, ACPI is kind of an unsafe solution. It's plug and play, and for security, it's not good. So that brings us then to, verification. So ONELab is already a step in the right direction, but it's very SystemReady centric. So that means we kind of openly prove that we are SystemReady. I tell you, customers don't care about SystemReady because they don't have this low volume, high mix. They only have one operating system they care about. What do they care about? SystemReady. So I think in the future we should, more go to a service like OS Ready that has a more heavy testing on the 80% of the OTA capable operating systems. Okay, but anyway, it's a step in the right direction, and we subscribe to that one. I have 3 slides that are my observations, because I do see that there's a big danger in the market. We are in a 30 or 40-year cycle, and our companies are quite old, actually, and have whatever. So, first of all, Intel. Intel occupies 80% of the embedded market, the current embedded market. Not the new market, not the AI stuff and everything like this. They will maintain that market share. It's very, very difficult to get rid of them. There's a really deep ecosystem entrenchment with a lot of, the vertical companies and domain knowledge tied into Intel. Very difficult to replace. Performance-wise, they occupy mid and high end, and that's where the money is. And then the biggest problem, cultural inertia. That is our inertia. The companies like us are very, very difficult to re-educate to do the right thing. I think Qualcomm has the same problem with these kind of things. Basically, you have to go outside to, to get their innovation. So that's, we either have to get ARM to, to the x86 side, or we have to reinvent the way our companies work, and that's going to be really difficult. SystemReady ONELab, I think it's standardization, so we subscribe to those kind of things because that's what we do with hardware. Well, I already said that. One of the other problems with the ARM ecosystem is, compared to Intel, it's very fragmented. So secure solutions are totally different if you look at NXP or probably the Qualcomm or MediaTek. They all have so the abstraction into PSA is kind of welcome. We really should strive for a true bias on ARM. DTS is a step in the right direction, but I think we need a higher abstraction. Then another problem is the SDKs. Again, Qualcomm mentioned this one also, that's good. Every silicon vendor only supports one distribution where they optimize for the optimized drivers and for the SDKs. So for NXP, this is Yocto or something like this. But if you go to Debian, you will not get these accelerators. The good thing is most of the customers, they don't really care. Or with the NXP side, they don't care. They just want to go with their favorite. Then another problem is Yocto lacks the structure for OTA deliveries. So most of the customers have to do it themselves. And we know that the bigger customers are capable of doing that. And then finally, a warning, don't underestimate Intel's entrenched position. I would say let ARM not try to take Intel market share. That's a very dumb way to do things. You have to focus on the new industries. That's where the opportunities are, because even AMD cannot get this market share. Okay, last one. The next decade, what I say, we either have to transition or we have to transition the ecosystem of ARM into the kind of x86 convenience space. On top of that, we have to be very careful because the Cyber Resilience Act is going to cost us so much work, and especially on the ARM side. I think ARM is a task. There was talk about Windows and ARM and emulation layers. Well, what about Linux? Linux doesn't have this problem with an install based on Linux for x86. There is also emulation has to happen on that side. Emulation is not everything, but it's a step in the right direction, because then you still have libraries, drivers, and things like that. So my point is, 30 years I've been looking at this market. It's not about battery life. It's not about speed. It's not about performance. It's about, how to say, the domain knowledge and things like that. So if you want to have the embedded market, you will have to learn to speak its language. Thank you very much. You.